welcome Graham Purvis. Graham's been a technical instructor with IBM and Global Knowledge for more than 20 years. He holds certifications on a broad range of topics and platforms. So Graham, after all that, I turn it over to you.
Good morning. How's everybody doing today? It's a beautiful morning to start talking about SQL Server. So I'm just going to drop my video for the rest of the session here just to limit the bandwidth that I'm actually sucking up. So we're going to talk about SQL Server today, but before we do that, just some administrivia. You should actually find a set of controls down at the bottom of the Zoom session. Your microphone and the video will be muted throughout the entirety of the session. So you have two channels of communication. You have two channels of communication, which are the Q&A as well as the chat session, as was just mentioned. So I am MCSE with Microsoft. I've been teaching Microsoft stuff from Windows NT 4 through to the current versions of the Windows Server operating system, Server 2019. I've been dealing with SQL Server since SQL Server 6.5, all the way through up to and including the current version. I'm not going to be able to actually handle questions during the actual session itself. So the questions have to go into the queue and we'll handle those once we actually finish up. So that's where I'm coming from for this material right here. So this is a general overview of SQL Server and some high availability options information associated with SQL Server. So SQL Server as a database was introduced by Microsoft back in about 1989. Versions of SQL Server between 1 and 6.5 were binary compatible with Sybase, and you could literally copy databases back and forth between the two platforms. With SQL Server 7, Microsoft actually modified the physical storage structure, and at that point, it became a completely separate product from its precursor. We have several milestone versions of SQL Server over the various different periods in time. SQL Server 2005 is a milestone version of SQL Server. SQL Server 2005, Microsoft actually changed the security paradigm for the SQL Server database, introducing the schema class object and changing the way that you actually interact with database metadata, which includes the hiding of all of some databases, things like that. So that was a sea change within SQL Server. We get up to about SQL Server 2012. Microsoft introduces the ability to actually use extended events for monitoring of the SQL Server about there. SQL Server 2014, Microsoft introduces new features such as what is in marketing terms called in-memory transaction processing, which is to say a optimistic locking model for transaction processing, which significantly can increase transactional throughput under special circumstances. SQL Server 2017 is also a milestone version of SQL Server. SQL Server 2017 is the first version of SQL Server which was released on Linux as well as on Windows. And I think the fact that Microsoft ported SQL Server over to Linux is really telling in terms of their ultimate long-term direction, where they recently scrapped their proprietary Edge browser in favor of a Chromium open source based Edge browser. If you take a look at some of the statistics associated with Azure, more than 40% of the virtual machines that are actually running in Azure are running non-Microsoft operating systems. Microsoft's adoption of GitHub as their development platform which is an open source or was an open source development platform. Microsoft's adoption of other open source technologies like Kubernetes and Docker. All of these are indicators or signposts as to Microsoft's future intent with regard to how they're going to be actually handling software development. SQL Server 2019 is the current version of SQL Server. When we take a look at the support life cycles for these, you'll note that SQL Server 2014 has mainstream support up to 2019 with extended support up to 2024. So if you're on SQL Server 2012 or below, you are moving towards the end of the extended support period because mainstream support for SQL Server 2012 ended in 2017, and the extended support is going to drop off in 2020. So realistically, you should, if possible, be looking to move up into SQL Server 2016 through to 2019 in the near future. You've only got, well, that's less than 2 years of lifespan on an SQL Server 2012 server. So you should be considering a migration if possible. When we take a look at the editions of SQL Server that are available, the Enterprise Edition is the flagship version of SQL Server. It incorporates 100% of all the features, functions, and capabilities that exist within the product at all. The Enterprise Edition has a number of high availability functionalities. So with the Enterprise Edition, if you deploy that in a cluster, you can actually have up to 25 instances running within a failover cluster if you're using standard SAN type storage. If you go to the SMB type storage, you can actually have up to 50 instances of SQL Server running inside of a cluster. You have the ability to actually set up a mirrored database, and when you set up a mirrored database, you can actually have a third witness server and have automatic failover. We also have the ability to actually set up an availability group, and within the availability group, you can have up to 9 mirrors within the Enterprise Edition. When you drop down to the standard edition, the licensing cost is significantly less. However, you drop a number of features. There are special features like online backup or online restore functionalities are available in the Enterprise Edition, not available in the standard edition. You drop down to 2 nodes in a cluster, things like that. There is a compact edition of SQL Server, which is designed for handheld devices. It's been around for some time, and the compact edition has some interesting capabilities, including the ability to do merge replication with a production level server running standard or enterprise. We also have Azure SQL Server Database. The Azure SQL Server database, I didn't bother actually giving the version number because the version of SQL Server is constantly in motion. What you get with Azure SQL Server database is whatever the current version is that they are actually providing you. You have no choice, no option as to maintaining older versions and etc. So it is always whatever Microsoft actually says is current. And further, a lot of features and functionalities are now being introduced in the Azure SQL Server first before they actually may arrive into the on-prem version. So traditionally, it has been the other way around, where the on-prem version has 100% of the feature set, and new features show up there first and then show up in the cloud service. But some of those functionalities are cloud specific and therefore showing up just in the cloud service. Having said that, the cloud variant of SQL is, strictly speaking, a subset of the functionality of the on-prem version of SQL Server. There are several features, functions, capabilities, and so forth that do not exist in the cloud variant of SQL Server, like file tables, things like that, which require interaction with the hardware of the underlying system. When we take a look at SQL Server 2017-2019, Microsoft introduces support for a build of SQL Server that actually runs on Linux. You can theoretically port this to just about any distribution of Linux yourself. However, Microsoft has opted to have direct support for Red Hat Enterprise, SUSE Linux Enterprise, and Ubuntu Server. Of the three, Microsoft puts most of its effort into the Ubuntu server because both Red Hat Enterprise and SUSE Linux Enterprise are enterprise grade products that you must have an appropriate, it's not a license per se, but like a support contract kind of thing in order to be able to actually operate those operating systems there. Whereas Ubuntu server is fundamentally distributed fully free, although there are free variants of Red Hat Enterprise and SUSE Linux Enterprise. There are free versions, but it is the enterprise editions that are directly supported here. We also have the ability to actually run SQL Server in a Docker container. When you actually take a look at the Docker container build of SUSE Linux, what you're going to find is that originally Microsoft was actually spinning up a Windows Server core with SQL Server actually deployed into it and actually built a Docker container around that. Microsoft seems to have left that behind, and the current SQL Server running in the Docker container is running the Linux operating system. If you're familiar with Docker containers and hence Kubernetes and the management infrastructures that are associated with that, you should be aware that there is a requirement that you execute a Docker container on top of a host operating system that has an identical operating system kernel. So when we actually take a look at this, if I'm running a Windows-based Docker container, I would have to have a Windows-based host. If therefore I'm running a Linux-based Docker container, I have to have a Linux host. There is a mechanism whereby I can actually have a Linux host OS running as a sort of a virtual machine on top of Windows, which runs Linux-based Docker containers. But logically, if I want to get the greatest possible performance container host, I'm going to actually run the operating system native on there. So although there is a Windows-based build of a Docker container that still exists, the primary distribution variants of Docker containers actually run Linux as opposed to Windows-based operating systems. When you actually run an installation of the SQL Server, you will actually have a number of options as to the groups of componentry that you actually deploy. You have the database engine. You also have an analysis services engine. When you deploy the analysis services engine, you create an analysis services database. Inside the analysis services database, you create data cubes, which require a multi-dimensional data structure. Microsoft had a literal multi-dimensional data store, but currently Microsoft has adopted an approach where the multi-dimensional data is actually stored in a relational database, ROLAP, as the default deployment there. And you can build various different analysis tools on top of the data cubes, which are then populated or pre-populated with data. So that's analysis services, the ability to actually run queries. There is a cloud variant of analysis services. However, Microsoft recently renamed it, and the new name's fallen at the back of my head. We then have integration services. Integration services in SQL Server is a set of componentry with which we can actually build integration services packages, which are designed to actually assist us in performing ETL or extract, transform, and load operations. So you build a package to move data from one location to another. If you're going to be doing those things scheduled or periodic basis. SQL Server also supports reporting services. Reporting services has its own custom web services interface. It runs a couple of SQL Server databases to actually hold config information. And what we can then do is we can upload RDL objects, which is report definition language objects, into the web interface. We can then execute the report options against the backend SQL Server databases. You could also connect to other data sources. There's connector strings that you actually define in there, and render reports inside of this web services interface. There are several end user functionalities where we can allow the end users to provide variables and things like that, allow the end users to actually set up scheduled executions of the reports and stuff like that. So that provides us with sort of a alternate interface through which both developers and end users can actually interact with the data that is in your backend databases. SQL Server supports a function called Master Data Services. Master Data Services is designed to maintain consistency across multiple instances of a database, which are distributed across multiple servers. We also have data quality services. Stream Insight allows us to actually monitor data as it's actually moving between systems. We then have full text search. The full text search functionality is an augmentation to the built-in indexing functionalities that you have inside the SQL Server. The built-in indexing functionalities in SQL Server are very, very efficient and effective when dealing with discrete values. So if I have a column of first names, a column of dates, a column of values like that, SQL Server's built-in indexing are very efficient at actually handling searches across that data. However, if I have, for example, a column which contains a document like a synopsis of a book or something like that, which is large blocks of random text, SQL Server's internal indexing can't handle that very well, in which case what Microsoft did was they took the search functionality out of the web server and they plugged it into the SQL Server. You then need to go in and identify which columns and which tables you want to have read into the indexing service. And then there's a special query language that you actually use in order to tell SQL Server, hey, don't you go and process this, hand this off to the search service. The search service will actually return a key list to identify the records where it believes those records are. SQL Server supports replication. There are several different implementations of replication. We have simple replication, which is based upon transactional operations, and you have the ability to actually set that up as bidirectional. It is unidirectional by default. We also have merge replication. You also have a form of replication that actually is ostensibly a scheduled bulk load of data. So there's a number of different replication implementations that are actually available on top of SQL Server in order to actually maintain multiple copies of data across multiple instances of SQL Server. Replication is one of those things, unfortunately, that because of the absence of an SQL Server agent in the Azure variant of SQL Server, that we don't have the ability to actually do up there. However, there is a method by which you could actually incorporate either an on-prem or an Azure virtual machine to actually run into an Azure instance of SQL Server. SQL Server supports Power Pivot, so that instead of running pivot operations in your client like Excel or whatever, you can actually have the SQL Server do the heavy lifting associated with that. We also have Power View. Polybase is a solution which is embedded into SQL Server, which will actually support submitting SQL-like queries to the SQL Server. The SQL Server will then actually pass those queries on to a NoSQL database. So as in the past several years, NoSQL or non-table-based database sources have actually come into the fore, and this provides you with the ability to run queries against your SQL Server, which will actually be serviced through a Hadoop Cloud or some other solution that is actually backending into a NoSQL database. That is also supported by machine learning services, which provide you with R and Python languages that you can actually run against your SQL Server, which again would normally backend into a NoSQL type database or a Hadoop cluster. SQL Server scalability. If I take a look at SQL Server, instances on a single physical computer, you can have up to a maximum of 50 instances on a standalone server. And in terms of licensing, licensing is actually handled with a single set of licensing across multiple instances of SQL Server. Instances within a cluster, you can have up to 50 instances in a SMB cluster and up to 25 instances of SQL Server running across a cluster where SAN storage is being used. Each instance of SQL Server can support up to 32,000 databases, and each database can be theoretically, anyway, up to 524,000 terabytes of storage. No limit on an individual table specifically, but limits on the overall size of the database as you actually assign multiple files to it. When we take a look at the compute capacity of the SQL Server for a single instance, the Enterprise edition of SQL Server has the ability to actually leverage whatever resources are available under the host operating system on a Windows-based server, data center edition. That would be 64 sockets multiplied by cores. So I believe something in the order of 600 cores can actually be leveraged theoretically by the SQL Server. However, if I'm actually running multiple instances on a single physical host, I'm probably going to limit the number of processors that an individual instance is able to actually access to actually distribute the available resources more equitably. When we take a look at maximum memory, again, the Enterprise Edition supports operating system maximum, which in the Windows Server 2019 Data Center Edition is 24 terabytes of RAM. The standard and other editions of SQL Server, however, have soft limits on the amount of resources that they can actually address. So this is a maximum with regard to the Enterprise Edition running on a data center edition of Windows Server. We have a number of client tools that are available for interacting with and managing SQL Server. Up at the top of the list, we have SSMS, which is the SQL Server Management Studio. The fundamental limitation on the SQL Server Management Studio is that it is a Win32 app. I do understand that somebody has actually got SSMS, an older version of SSMS, to run on top of Wine, on top of Linux, but it's really a Win32 app built on top of Visual Studio, basically, and is a Windows-only tool. We then have SSDT, the SQL Server Data Tools. The SQL Server Data Tools are a set of plugins to Visual Studio, and those plugins to Visual Studio allow us to go through and use development functionalities for reporting services, for analysis services, and things like that. Those, of course, are limited to only systems where you can install Visual Studio, which is still, as far as I'm aware, Windows-based only. You have SQL CMD, a set of command line utilities. SQL CMD used to be automatically included with the Management Studio. You now have to download and install that separately. And the SQL CMD command line interfaces, which includes SQL CMD and the BCP utility, are now cross-platform. So you can actually install that and execute queries from a Windows machine, Linux machine, or a Mac OS device. There is a set of PowerShell modules associated with administering SQL Server, and PowerShell itself is now cross-platform, so you can actually deploy PowerShell to Windows, Linux, or Mac, so it's cross-platform. Azure Data Studio. Azure Data Studio, I would not I would not place it as a replacement for the Management Studio. It's certainly missing much of the functionality of the Management Studio. However, it is cross-platform, and it does have some functionalities which are not present within the standard Management Studio. Two of those functionalities inside the Azure Data Studio include the ability to actually use Jupyter notebooks and the ability to actually insert widgets into the management tool so that you can actually see what is effectively graphics representations of reporting right within the management tools. That's a functionality that's not available in SQL Server Management Studio. It's also fully cross-platform. We also have Visual Studio Code. Visual Studio Code by itself is not an SQL Server client. However, it has a plugin module for interactions with SQL Server, and it also is cross-platform. So you can see with Visual Studio Code, Azure Data Studio, that Microsoft is actually pushing forward with a cross-platform strategy where you can actually run your SQL Server database workloads on either Linux or Windows-based foundations. We also have a set of tools that are cloud-based, including Azure Data Factory. And we also have a utility called the SQL Server Migration Assistant. That is Windows only. The SQL Server Migration Assistant has a series of toolings to allow us to actually connect to various different data sources, such as Access and so forth, and Oracle Server, so that we can actually migrate data from those data sources into an SQL Server database. One side note, SQL Server Management Studio still actually installs a set of monitoring and management tools alongside of it, including the database optimization tools and the database tracing tools that are actually incorporated there. So some specific reasons to actually use the SQL Server Management Studio as the primary for managing SQL Server. And when you're actually using the Management Studio, you still have the ability to connect to and manage both Windows-based and Linux-based operating system hosted SQL Server instances. There are some functionalities that don't work on Linux, like Windows-based authentication and stuff like that. But nonetheless, you have those capabilities. When we take a look at some of the features that have been introduced in more recent versions of SQL Server, SQL Server 2014 introduced in-memory OLTP, a optimistic locking variant of transaction processing, and the buffer pool extension. Buffer pool extension is for servers that have limited RAM resources, allowing SQL Server ostensibly to actually handle its own swapping. SQL Server 2016 introduced temporal tables, the ability to go to retain revisions of every single record that has ever existed inside the table and be able to actually query through to the table based upon time variations. So I can actually say, what did this table data look like on January 1st of last year, something like that. We also support Always Encrypted, which is a client-side technology that allows the client to go through and encrypt the values, which will be stored in a column. So this is ostensibly column-based encryption, where the client is doing the encryption and hence the server does not have access to the data. They also introduced dynamic data masking, the ability to actually return an alternate version of the data depending on the permissions of the user. So if I do not have permissions to see a credit, instead of actually returning the credit card number, the SQL Server will return a placeholder for the credit card number, that sort of thing. They also introduced row-level security and stretch databases. A stretch database is a database solution where a single individual table in an on-prem SQL server holds a certain quantity of data locally, and the remaining data is actually pushed out to an instance of SQL Server running in Azure. You then get ostensibly unlimited storage capacity, because as long as you can afford to pay for whatever you're actually shoving out to Azure, the table itself and the local storage of the table is going to be only that portion of the table that you consider to be active portions of the data. SQL Server 2017 introduced automatic database tuning, specifically the ability to actually do and regression automatically within the SQL Server, Linux support, and SQL Server machine learning services, and support for Python and R languages introduced in SQL Server 2017. We then, in SQL Server 2019, introduce always encrypted secure enclaves. So we introduced always encrypted up here, where the client was doing the encryption, the server didn't have access to the data. Secure enclaves is a small virtual machine running physically on the server. I provide that with the encryption keys, which are normally available only in the client. The server then has the ability to actually process data operations against the encrypted data, where the SQL Server itself is still unable to go through and actually see the data. Data discovery and classification, as well as labeling and protecting of sensitive data, introduced also in SQL Server 2019 in the on-prem edition. If you take a look at Azure, Azure has a similar set of functionalities for identifying and labeling data and applying security to data on that basis. When we take a look at HighAvailability Solutions for the on-prem implementation of SQL Server, there are several technologies that you could actually consider. The top of the list here is always on availability groups. It's available in the Enterprise Edition of SQL Server. However, there is a limited variant that is available in the Standard Edition. When you take a look at an always-on availability group, what you're actually looking at is going to be a solution whereby you actually set up a series of mirrors of a database. However, unlike standard database mirroring, client must be aware of which server is the primary and which server is the mirror, and it is the client which fails over from the primary to the mirror when the mirror becomes unavailable, and the mirror and the witness decide to actually bring the mirror online. In an availability group, you run that within the context of a failover cluster under the operating system, and there's a cluster-based service which then provides control and distribution of queries to the appropriate instance of SQL Server on a database by database basis. So availability groups are availability based at the database level. And what you're going to have is exactly one read-write copy of the database, multiple read-only mirrors of the database, but the cluster service has the ability to direct traffic. So if the traffic is read-write based traffic, it's going to be forwarded to the read-write instance, whereas if the traffic is read-only traffic, it can be forwarded to one of the designated read-only instances for handling. And so with availability groups, you actually get the ability to increase the throughput of your database by leveraging multiple instances, depending on the nature of the queries that are actually coming into the cluster control. We then have always-on failover clusters. Again, the always-on here is sort of a marketing label that's been thrown on here as compared to Oracle's unbreakable clusters, I guess. So we have failover clustering instances. SQL Server has had the ability to run within a failover cluster for many, many generations, going all the way back to SQL Server 2000. And that's available in both the Enterprise and Standard editions. However, the Enterprise edition has scalability significantly beyond the Standard edition. Standard edition is 2-node clusters only. We then have database replication. All variants of SQL Server have the ability to engage in some form of replication, down to and including the mobile variant. We also have database mirroring. It's available in both the Enterprise and Standard Edition. Database mirroring in the Enterprise Edition supports dynamic failover by utilizing a witness server to allow the mirror to come online automatically. The Standard Edition requires manual failover, and both of those solutions require that the .NET Framework-based client application be configured with the identity, the primary, and the identity mirror, because when the primary goes offline, it is the client that connects over to the mirror. There's no server-side functionality which redirects clients. We have the ability to actually deploy SQL Server into a federated database solution. A federated database solution is a scalability solution where we determine that a single physical database can't be handled on a single server. So what we're going to do is we are going to break the database into smaller chunks and actually have different chunks of the database distributed across different instances of SQL Server. There are some tools, specifically Azure-based tools, that are designed to assist us with sharding of the database, and a shard map is generated in order to identify where specific pieces of the database are, so that we can automate the process of redirecting traffic to the correct instance of SQL Server. So that's scale out databases with the shard mapper, which is a Azure functionality. The shard mapper is an Azure functionality. You also have log shipping. Log shipping allows us to actually run a warm standby server, and Microsoft licensing in recent versions of SQL Server accommodates that by not billing you for the standby server until you actually bring it into production use. And we also have what is referred to as host clustering. Host clustering refers to not clustering of the SQL Server instance, but running the SQL Server on in a virtual machine, where the virtual machine is running in a highly available clustered solution, and hence the database itself is fundamentally unaware of the high availability solution that underlies it, and you can combine solutions. So I can have host clustering with a failover cluster, or host clustering with an availability group, in order to provide additional availability to this. So when we take a look at some of the details associated with the different solutions here, if we take a look on availability groups, always on availability groups has one read-write primary replica. You always have one per cluster, and you can have up to 8 secondaries. Of those 8 secondaries, which are all read-only, you can have up to 4 synchronous secondaries. The others would be asynchronous. And depending on the version, SQL Server 2016 supported up to 2 synchronous, 2017, 3 synchronous, and 2019, 4 synchronous replicas. When we take a look at this, we have availability modes, which is synchronous commit mode. We have automatic failover and manual failover capabilities here. So I can actually force the read-write replica to be moved from one node in the availability group to another node in the availability group. So when we take a look at deploying SQL Server in a failover cluster deployment, when we take a look at a Windows failover cluster, the operating system can have up to 64 nodes in the cluster. The SQL Server, provided you're using SMB-based storage, can actually have up to 50 instances across your 64 nodes inside of the cluster. And secondarily, we have the ability to do host clustering as well as SQL Server clustering itself. When we take a look at replication solutions, we have transactional replication, which is going to monitor transaction execution operations based upon the transaction log and move the transactional activity from the server where the transactional activity originally occurred to the replica server. Please note, all variants of replication introduce latency. If you cannot allow latency, you have to use database mirror as opposed to a replication solution. One of the strengths, however, of replication is that when you actually set up replication, you don't necessarily replicate the entire database as such. The replica databases can actually physically have a different schema than the primary database in the replica. And hence, I can optimize the primary database for read-write activity and optimize one of the replicas for read-only activity, having different indexing strategies and things like that across the two databases, because the databases do not have to be physically identical. We don't replicate at the database level. We replicate at what is referred to as the article level. Each article represents a subset of data from an individual table. So we have transactional replication. Merge replication facilitates allowing any node participating in the replication to actually make modifications to the data, and we'll sort it out once it's actually replicated to the other nodes. We have snapshot replication, which is basically a bulk load option for replication. Transactional replication supports peer-to-peer mode, in which case we can actually have the data going in both directions. And we also have updatable subscriptions so that you can actually make modifications to a subscription and have that flow backwards. We also have the ability to have subscribers that are non-SQL servers, theoretically. Oracle Server, for example, you can send data to an Oracle server. It's also possible to have a non-SQL source. So I can have like an Oracle server that is actually the source where the replication engine is running on top of the SQL server, where the SQL Server agent is actually deployed. When we take a look at security features inside SQL Server, there are many. Firstly, when we're actually sending data across the wire, you can configure your SQL Server to do TLS. It is native to both the SQL Server and the SQL Server client. The limitation in this particular case is that you must properly mint a TLS or SSL certificate for the SQL Server and manually bind that digital certificate to the SQL Server. Until you have done those two things, your SQL Server is unable to actually do encryption at the transport layer. And therefore, by default, all your SQL Server traffic is flowing in clear text across the wire. So something you really, really need to consider and ensure that you have an encryption solution for your SQL Server. Where TLS is layer 7, that is application layer encryption, we also can institute IPsec, which is layer 3 or network layer encryption, which would be ostensibly transparent to the SQL Server, but has the secondary advantage of the ability to actually do mutual authentication between the two devices that are engaging in an IPsec session. So IPsec is going to be operating system dependent, whereas TLS, provided that you mint and issue the appropriate digital certificates for SSL and you bind that to the SQL Server, is available across all editions of SQL Server. We also have transparent database encryption. Transparent database encryption is going to encrypt the storage of the SQL Server at the page level. Hence, if somebody were to gain access to files and try to mount them on a server where the appropriate public and private key pair were not present, they would not be able to actually decrypt the data that was in the data pages of the SQL Server. This meets a number of requirements for protecting the data at rest. We also support column level encryption, where we can actually encrypt the values that are stored within a column, within a table inside of the database. Always encrypted, which was introduced in SQL Server 2014, is also ostensibly column level encryption. The difference is with column level encryption, the encryption keys are on the server. So it is the server that both encrypts and decrypts. Hence, the data goes to the client unencrypted, unless, of course, you're using one of the transport level encryptions up here. So the data is decrypted by the server and always encrypted. The data goes across the wire encrypted encrypted by the client. We also have support for encrypted backups. In addition to all of those technologies under security, we have server auditing, which we can actually monitor all activity that is actually going on inside the server and have a forensic analysis of activities. SQL Server 2019 supports data classification along with auditing. We also have dynamic data masking, which allows us to, based upon permissions, hide data from the users. And we also have row level security. That is the ability to have different sets of permissions on different groups of records inside of the same table. Whereas older versions of SQL Server, permissions were actually defined at the table level, ostensibly. When we move up and actually take a look at Azure, there are a number of database offerings that are actually in Azure. There's the Azure SQL Server database, which is their flagship database platform. It's a platform as a service offering. You do not have visibility into the underlying physical infrastructure, although I can actually talk about how that is actually instituted a little bit later. So we then have the ability to actually spin up a virtual machine in Azure and install SQL Server into the virtual machine. In fact, there are several image templates in Azure which already have SQL Server and include SQL Server licensing in the per minute costs associated with actually running the virtual machines. When you actually compare the two, if you actually run a virtual machine in Azure and you install an instance of SQL Server into the virtual machine, you get 100% of the capabilities of that version of SQL Server. So the virtual machine server provides you with fundamentally identical capabilities to the on-prem version of SQL Server, where on-prem we often run the SQL Server inside of a virtual machine as well, right? So we have 100% feature compatibility between the on-prem version and a version running in a virtual machine in Azure. We then have Azure Synapse, which is ostensibly the new name for analysis services in Azure. We also have Azure HD Insight, which is a Hadoop implementation that is a solution for running a NoSQL database and actually running large scale queries across a NoSQL database. We have Cosmos DB, which is in actuality MongoDB, and this open source database. Azure also has an implementation of MySQL, as well as PostgreSQL and MariaDB. In Azure, we also have Azure Data Lake Analytics, which is basically storage-based data management. Basically, you're incorporating a storage account, a Hadoop cluster, and your analysis services, the Synapse database, all into one package there. So there are numerous database offerings in Azure, and only one of those is the SQL Server. There is an SQL Server managed instance as well, which has some additional features which are similar to the on-prem implementation. So it's more, it has a closer feature parity to the on-prem version of SQL Server. When we take a look at an Azure instance of SQL Server, depending on the option that you actually choose, you will end up with a highly available solution. If you choose basic, standard, or the general purpose tier, there are two different licensing modes. Basic and standard are transactional throughput based licensing, whereas this one is a vCore based licensing model here. In all three of these solutions right here, you get what is ostensibly a failover cluster. So you have an instance of SQL Server, which is actually running on top of a highly available solution, basically clustered, and we maintain high availability by holding the data in highly available storage. When you approach the Azure instance of SQL Server, you hit an edge node in Azure, and the edge node is going to pass you through a gateway ring, which actually provides communication inbound and uses virtualized networking technologies in order to route your communications to the SQL Server instance wherever it happens to be within the regional data center. So your standard SQL Server instance running in a Azure scenario is going to be highly available because it is ostensibly clustered. When you actually go to the premium and business critical tiers, premium is transaction-based licensing, and business critical service tiers are the vCore-based licensing model. You still have an edge device, you still have the Azure region. However, what you end up with is ostensibly an availability group. So within the availability group, you will actually have a primary read-write replica, and the gateway ring will forward all write-oriented communications to the primary read-write replica. You can then actually have secondary replicas, and the secondary replicas can be read-only or will be read-only. When you actually take a look at this, depending on the model that you actually choose, you can have multiple replicas, and one of the secondary replicas can be physically in another region, read different data center in a different location. So that provides us with very, very high scalability for the premium business critical tiers. You also have a couple of other features in Azure with regard primarily to licensing. So an elastic data pool has nothing to do with the performance of an individual instance of SQL Server. It has to do with how you provide DTU licensing across multiple instances of SQL Server. There's no performance there. Okay, we're running very, very tight to the end here. I'm going to go back and actually take a look at some of the questions in the question queue. So there's a question here, what is the need for software assurance licensing option? Well, when you actually purchase an on-prem license for any Microsoft product, software assurance is Microsoft's solution for providing you with updates, upgrades, and so forth to that product over time. So by and large, you kind of don't have an option there. You kind of have to actually purchase some sort of ongoing licensing, and software assurance is usually the simplest overall solution for that. Having said that, I don't deal a huge amount with licensing of SQL Server, so the best way to actually address that would be to talk to a value-added reseller, get their opinions with regard to the most cost-effective method to license your on-prem SQL servers, and compare that against the information that's coming direct back from Microsoft, and make your determination as to how you want to license your instance through that. There's a question there, are SQL Server new features cumulative? And the answer is ostensibly yes. As you go from version to version to version, all the new features end up in future versions. Having said that, with each new version of SQL Server that is released, some features are deprecated, language elements disappear. So not everything that has ever existed in SQL Server still exists in SQL Server. So with every new version of SQL Server, there is a deprecation report identifying features that are going to be removed and features that have been removed from the SQL Server. When you actually take a look once again at licensing, there are a couple of different models for licensing access to the SQL Server. There is user-based licensing and device-based licensing, as well as the licensing of the SQL Server itself. If you have multiple instances of SQL Server running on the same physical machine, whichever device or user licensing you hold should actually cover you for connectivity into multiple instances running on the same machine. And I believe that also crosses over into the cluster. But once again, licensing is not my specialty here. So the best way to actually evaluate licensing would be to talk to either Microsoft directly or a value-added reseller, okay? Is SQL Server migration available on Linux? The migration tools run on a system, and you perform what is ostensibly an extract from the original data source and a load onto the destination. Therefore, yes, you could actually load data into a Linux variant of SQL Server because the SQL Server client software is going to support that. At this point, I'm not able, I'm teaching a class, a regular class in 3 minutes. So I don't have time to actually look at deprecation. What you'd have to do is every time Microsoft releases a new version of SQL Server, that new version comes out with a document that identifies all the new features, new functionalities, and et cetera, and will also identify the deprecated features. So you'd have to go and actually do some research, but Microsoft does provide that documentation.
Hey, thank you so much, Graham. I don't want to cut you off, but I also want to respect your time here. I know you've got a class to teach. Thank you again for showing up today, and this has been a fantastic presentation. Thank you to everyone that has engaged and asked wonderful questions. I know we can't get to them all, so I would encourage you to please reach out to our social media team, whether that be via Twitter, LinkedIn, Facebook, Instagram, whatever. Let's make them earn their paychecks. So any questions you may have, shoot it out to them, and they can hook you guys up with an answer. And finally, be sure to continue to visit Global Knowledge's website to access free additional resources like technical articles, white papers, and fantastic webinars like this. Just a friendly reminder, you will receive a recording of this presentation in about a week. So look for that. We do not provide the actual slides. It's just a recording of the presentation. So with that, everyone have a wonderful rest of your day, and be well.